My guest today is Adi Polak. Adi, how are you today?
Fantastic. How are you?
I'm doing really well. It's good to see you again. I was hoping to see you in London, but I understand that things didn't work out quite right.
Right. It's been a while.
You're what? Tell me what you're doing these days.
Yes. So I'm heading developer advocacy at Confluent, and I'm also managing our DevRel engineers, uh, two fun teams to work with as part of the developer relations. And yeah, we're actually working on some very, very exciting technology and innovation in that
That's what I
space.
heard. Tell me about it. Tell me about a cool project you're working on.
Oh, there's so many cool projects. Well, perhaps I can give a little bit of a background about what Confluent does.
Sure.
Um, So Confluent built the data streaming platform. Essentially, everything an engineer, an architect, software developer, anyone that needs anything related to data streaming processing, we have these capabilities from Kafka to Flink to creating your own streaming SQL applications to governance to catalogs. We got it all, and we actually build it into a very nice organized manner, so it's easy to get started and it's easy to build data streaming applications. Now, data streaming as technology has existed for so many years, but the interesting thing, and I believe this is what David, you and I wanted to talk about, is actually how does technologies address some of the challenges we're seeing today in software.
What kind of challenges?
Yes, the challenges is a good. That's a good question. So maybe you've heard about this term. It's quite popular now in the industry. This is agentic AI. And
Agentic
agentic AI,
AI.
right? It's not agents. Well, it's also agents, but it's also kind of like a new word that became more popular. Agentic. It didn't exist in the vocabulary before, but now it does, and it does with the combination of AI. Now, perhaps I can start with you know short example, things that people heard about more, and this is RAG. RAG is retriever augmented generation. This is our capability of actually enriching an existing LLMs with context, so we can ground the response of this LLM in facts.
Mhm.
And this is something that we've been talking about in the industry for the last 2 or 3 years. Um, RAG is not a new technology. By the way, there's two very common patterns that exist in RAG. One is the term retriever. Uh, Technology that existed for years and years. For example, if you heard about companies like Elasticsearch or technology like OpenSearch, they already have that implement. The challenge with that is that you have to know exactly what is the term that you're looking for. So if you know the term, you can find a solution in an existing document or in corpus of documents.
Mhm.
The second pattern that also is very, very interesting, this is the embedding. So retriever embedding, this is when we actually take the data and compose it into embedding structure into a vector that enable us to do search based on similarity. So here as a user, for example, I don't need to know the exact term that I'm looking for. The similarity algorithm is going to find things that are similar enough to my question,
Mhm.
so it will retrieve the information that I need. So this is high level when we're talking about RAG. Now you're probably curious how. So what is an agent, right? Like what
What is an agent, Adi?
what is an agent? It's a very philosophical question. It could be, but also practical and technical. So the practical and technical part is when we as a user generating any question to a chatbot, to an LLM, to an application, and our steps, some of the steps of creating that prompt, so taking our query, massaging a little bit our query with the prompt, and then getting the data back from a RAG or any database that exists out there, this is actually the process of an agent. There is an application that is responsible to communicate with a database, with a facts database, that retrieves that information that I need in order to enrich the prompt. So this is
Okay.
one of the basics agent. Agentic RAG is one of the very basic types of agents.
So maybe if I'm asking a question in a natural language like English, then the answer to that question, it might be out on the web. That's what Bing and Google do. They kind of index all the public websites, or it might be in some repository like a database or a document store or something like that.
Exactly. Exactly. And embedding, in the world of embedding, perhaps, you hear a lot of vector database, vector similarities, which open up a new portal for us as as humans, as user, not to know the exact term. So it gives us that flexibility of being able to research, not based on a specific term that we know, but based on things that we heard of or things that we can articulate and communicate. Now, as you can imagine, this is very simplified approach. You and I going into any chat experience and asking for specific questions. This is one aspect of that. Um, in the industry, what companies are now starting to build with agents even become more bigger and bigger, because usually when I'm building an architecture with an agent, what the agent will do when it kind of wakes up, when the application starts, I'll do a discovery.
Okay.
And during that discovery phase, it's going to see what kind of tools it has in order to answer any questions or tackle any challenges and goals.
What do you mean by tools?
Great question. So tools can be anything that I am as a developer providing my agent with. For example, I can provide it with templates for running queries on my database. I can give it a list of databases and access to them so it knows where to go for what query. I can give it access to search the web. I can give it access to my telemetric information, to my logs, right? If I'm building, if I have an application that runs and it creates logs, I can give it access to the logs that I want. So essentially, a tool can be anything and everything I can give my agent a free access to. And of course, as it grows, we'll need to govern it, we'll need to secure it. But at the very basics is things that the agent can take and start running on its own. Um, Very similar to how we build application up until today. The only and it's a big difference. The only difference now is we're not telling it what to do sequentially. We're actually going to leverage an LLM. It's another agent that is responsible to do the planning.
Okay.
So here, it's not, here's a step by step, please execute it. It's, here's a goal. This is what I want you to achieve. Give me the answer to this thing. Here are where your tools are going to be. Start discovering it. Here's the planner. Now figure out what can you do. I can give more specific example if that helps.
I think it would. Yes, please.
Okay, fantastic. So let's say we're creating, we have a fashion business, right? We're creating new collections every season.
Okay.
And one of the questions that I might have in my business is, please project the sales for the next 3 months for this new campaign that I just launched. Um, this is a question that a lot of business owners or a lot of people that work in data science and data analysts ask themselves, like, how do we answer this question? And this can actually be translated into an agentic model. So how do we go about that? Let's say my agent wakes up, it has a controller, it does the discovery, it understands that it has access to previous sales data. And so the planner, the planner says, gives us instruction of what the controller should run. So we're sending a request for the planner. Here's my questions. Here are the available tools. What can I do with that? The planner will send back a response saying, hey, you know what? You need to generate this SQL query, and you need to run this SQL query. And then you bring back the result and you send it to what we called a judge. So a judge is another agent that decides if this answer is good enough or not. And so in between these different applications of agents, we get a lot of different HTTP calls, request response, and so on. And let's say I got some information and, I got the projected of sales and I'm sending it to the judge. And now the judge say, um, you know, The answer is not good enough because you didn't look at marketing campaign data.
Oh, the judge is smart enough to know that you haven't looked at all the correct data.
Exactly, because this is
Hmm.
the role of the judge, is to judge the operations and the planning. And so it has access to our catalog and what exists in the company.
Hmm.
So the judge will send it back to the controller and say, you didn't complete your mission. Here's an additional information, send it back to the planner. And so now the planner is going to look for that campaign data that it missed earlier on in order to perfect the result at the end. And now
Hmm.
that we have the marketing campaign data, we can find, we can give a solution. The agents can give a solution that it's much more concrete and based on the real data and not only previous sales. And these type of uh, systems are getting more and more complicated and more in use. Uh, I gave an example of a business of how we, if we have a fashion business and we want to run this type, but there's also a notion of code assistants, right? Like
Oh, existence.
Copilot, like other code assistants that we have. Code assistant essentially has a UI, something that developers wants to use. And then there are different applications between that enables us to write a better code as engineers. So there's a server somewhere in the cloud that takes these requests of the code that we wrote, or if we ask a specific question about what this library does, and it starts an agentic process in house, matching some of the existing databases, some of the existing code that we already have. For example, if it's attached to something like my, organizational GitHub, it can also tell me what exists inside my code, right? And my company's code. So I can already leverage an existing code that's available there. And that code assistant is actually enables me to produce code much faster and be more efficient. But how does it? What would trigger that assistant to even start kicking off? So one is build errors, right? I want to build my software. I got some error that could trigger my assistant. Hey, we got an error. Start searching, start understanding inside the database that we have, or search the web or search Stack Overflow or any tool that we essentially have in order to understand how can we solve it and suggest a solution. So it
Hmm.
will try to give me autocomplete, where to go, highlight maybe a line that it's problematic for me as a developer. So this is one thing. The second thing, usually code assistants will go and will scan my code for patterns. And it could be, it's continuously leveraging our and learning and basing it on what already exists in my company. So it can help me identify the patterns that already exist and help me become a better developer by suggesting these patterns to me or even
Hmm.
writing the template code. And this is again based on the agentic model, because what we have in the end, we have different microservices that are running somewhere in the cloud where each one of them is responsible for a specific solution, right? A specific, like invoking a SQL or a SQL generator or invoking a SQL executor that needs to communicate and return back a result or take action based on these results. And it might sound familiar, the world of microservices, to many of developers, because microservices is not a new space. It's something that, as engineers, we saw a lot of challenges that exist in it. One of the prevalent ones is, how do we manage all these events coming into our system, right? How do we make sure we are on top of that and we're actually processing all the events? Nothing is being lost. And one of the solutions we came up with in the industry, it's actually a best practice and well known. This is event brokers. Let me put
Okay.
everything in an event broker
Okay.
and organize, my producer and consumer, producer applications, consumer applications. So I kind of already start to organize it in a way where I am um, building it so I'm not going to lose any events, and I'm going to process all the events that comes up, and my system will be complete and provide the user with the action that they're expecting the system to do.
So as this broker is trying to determine, it collects an event is something like you mentioned a build error. That's a trigger, and that's what goes to the event broker. The event broker is responsible for figuring out which agents to call. Is that the idea? To asynchronously call them?
So no, the event broker is solely responsible for keeping immutable log,
Okay.
in infinite immutable block that I can trust that the data is not getting lost.
Okay.
Because
All right.
what could happen before that is I'm sending a request response. It could be that, my request didn't get in on time. There was some idle time, and then my server dropped that request.
Got it. So this is just a way of asynchronously processing things so that no messages get lost.
Exactly. No messages get lost, no events getting lost. And so my system is more coherent
Got it.
around that. And, create reliability. It helps me build a solution that my user love and trust. And so I need that event broker, and that event broker is something that we already solved in the industry, in the open source space. A lot of people use Apache Kafka, for example, for that. And this is actually the very basics when we're building these agent systems that goes beyond just a simple use case, or beyond just a proof of concept, that helps us scale this architecture and start adopting best practices that are relevant to this world. On top of that, because we do have events that are being generated, we can also start building different tools to enrich those events. And this is where it becomes, we can expand the work that we're doing on top of it, for example, with stream processing solutions like Apache Flink. Apache Flink at the very core is built with the best practices for data stream processing. Apache Flink is an open source, part of the Apache Foundation, and it exposed multiple APIs for us as developers to actually do these transformations on top of that data in real time. So if I have in Kafka, I'm saving all my events, Flink can take these events and start processing and enriching them according to what I need, and then syncing it back into Kafka for any applications to take and start processing. And that's another best practice that we have, because sometimes these events will need to be either joined, they need to be filtered out. Some of them might be irrelevant for a specific user. For example, I can be a user that defines that my code assistant, I don't want my code assistant to deal with build errors. This is something that I can configure today. I'm clicking a check mark. I'm not gonna get support for build errors. And so these events, Flink can filter for me based on what it knows, right? Based on what it knows about how I configured the system, how I want this product to work for me and my organization. And so Flink existed for many years now, and again, it's not new. Very very similar to Kafka, and the fact that it can work on streaming data and it supports the Kafka latency, that creates a very appealing solution for me. On top of that, just because I want to complicate it a little bit more, but it's really
Please.
driven, it's really driven from real pain that we had as engineers. Um, this is idempotency, is our ability to trust that the system is going to process each and every event exactly once.
Okay.
It's important that, my system is going to react to all the events, because if it's not, I'm going to get a bad experience.
Right.
It's also important that, different scenarios like code assistant, my system will react exactly once. So I'm not getting suggestions for the same build error twice.
Right.
And that becomes even more important because of how LLM works. Have you ever tried submitting the same question to an LLM?
I probably have, but I don't remember what happened. What does happen?
Yeah, so usually we'll get different response.
Oh, I see. You mean I thought you meant right away answer the same question, but Yeah, if I ask a question today and the same question tomorrow, it's non-deterministic what the results are.
Exactly. The results are not deterministics because how LLM itself is built in its core.
Right.
So, how LLM itself is built on its core, there's something called temperature. Temperature adds a level of randomness to my LLM so it feels like it's more of a thinker, of a planner. And so a lot of my agents are built on exactly that. And there's a specific temperature, so the response are likely not going to be the same.
Sure. Sometimes that's really nice because if you don't like the first answer, you can ask the
Right.
question again and get a better answer. Sometimes it's frustrating because you think it has the answer. Which, if they're contradictory answers, which one do you believe?
Exactly. Exactly. And this is the exact reason why idempotency is so important in agentic AI systems,
Yeah.
especially
Oh, define
here.
that word. Idempotency, please.
Yeah, so idempotency means that I'm going to process a specific event exactly once.
Okay.
Not less than once, not more than once, but exactly once.
All right. Thank you.
And yeah, no, it's a great question. And yeah, that adds to the reliability of my system. Essentially, the fact that I'm able to have that as a best practice in a pattern. And now that we talked a little bit about the architecture part and we understand we have that, we need event driven, we need the event brokers, we need things like Apache Kafka and Apache Flink. I am now looking into two distributed systems, right? That each one of them operates on their own. And so I need to have this consistency of exactly ones in between those systems. And so there is something that's called two-phase commit
Mm-hmm.
in Flink. So Flink created this protocol of two-phase external two-phase commit. So Flink itself has its consistency that we can define, but when it connects to other tools like Kafka, we can also implement the protocol that Flink's required in order to have that consistency of the events of exactly once, this event guarantee with Kafka as well. And this is through the two-phase commit protocol. Now, this solution exists, right? So we don't need to implement it from scratch. Uh, we're just, nerding out about what they are and so on. But because all of these things exist, I can already leverage that for my agents. I'm going to complicate it more. Are you ready?
I'm ready.
Another thing that my agent needs are caching.
Right.
I need short memory and long term memory, what we call context, short term context and long term context, which again means that I need to be able to use tools that are actually going to give me that caching capabilities in order to remember what happened with a specific session and a specific user. And I can tap into the solutions that I just talked about before with Kafka and Flink in order to leverage the caching mechanism through the event system. Because Kafka already has storage attached to it. And Flink also has storage attached to it. It doesn't save information, it's a compute layer, but it is stateful. It runs our streaming in stateful. And stateful means that I'm retaining the state in between different iterations, which can act as my caching and my
Got it.
short-term context
Yeah,
mechanism.
the system remembers the last communication you had with it, or maybe
Exactly.
the last 10 communications or whatever.
Yes, the system remembers. And this is what we need with agents. So that gives me a solid infrastructure in order to start and build those agents, especially when I need to scale it beyond POC.
All right, so let's see. We've got, oh my gosh, there's a lot of moving pieces here. We've got the trigger, which I was always thinking of these as chatbots, but you said it could be something like just a build error. It could be something without human intervention. We've got the planner. Well, first of all, we got the event broker, which guarantees delivery once, doesn't lose any messages. We've got a planner that decides which one of our agents are going to get called. We've got a judge that, after executing that agent, determines whether that's enough, and if it's not enough, sends it back to the planner and says, give us more information. And we've got caching to keep track of the state of the conversation as it
Yes.
goes on. Those are I think they're all the pieces that are involved in this. I may
Yes.
be
Yeah.
missing one.
No, no, you're good. It's discovery in the beginning, where the agent wakes up and discovers the tools that it has that it can use.
Got it. Okay.
Yeah.
Uh, and we're almost at time here, but tell me what are some of the things that you are building? Are you building specifically things? Are they products or are they things that you're building custom for your customers?
Yes. So we're working on some very interesting edge cases now around agents and understanding how we can provide users of these two open sources with more capabilities for building agents, for example. So the two-phase commit one that came into was implemented on both sides with Flink and Kafka. I'm happy to share that it works really, really well. We have already introduced into Flink some new capabilities around better management of exceptions. So now we're
Hmm.
built in the ability to share more context about specific exception. So anyone who, if they're using agents or due to the Azure system, they can tap into that extra context that we're giving in a managed way in order to analyze what happened and give better suggestions. Um, Yes, and we're building other interesting capabilities specifically on Confluent, and this is more of a proprietary, but for people who are curious about Confluent, uh, we are exposing something called Flink AI. And Flink AI is a way for a Confluent customer to register an existing model and use it in Flink or to enrich the data or do any manipulations on the data. So that means I can use, if I'm looking at Microsoft, I can use the existing OpenAI models on Azure. If I'm looking at other providers, I can register them as models that my Flink can query and send queries to. And that gives me a more holistic solution where when these events are being processed right in there, if I want to already add the brain of an existing LLM or existing model, I can do it. Again, proprietary on Confluent for Confluent customers, yet it does enables very, very interesting use cases where we're actually seeing now some of the existing application, especially ones that are repetitive, like, you know, get me a transcript of that video or generate that SQL query, is something that it becomes a transformer in my Flink application. Yes, leveraging an LLM brain, but it becomes a transformer because it's so granular. It becomes a transformer, and so I don't need to spin a new application and new microservices uh, necessarily for only that. So this is some of the exciting things that I see, and I believe it's going to grow. We see a lot of excitement from our customers around agents.
That's awesome. This is a technology that's moving very fast and sounds like you're on the cutting edge of it. Adi, thank you so much. I've learned a lot today. I appreciate your time.
Likewise, David. So thank you so much for having me. It was a pleasure. Best technology innovations are the one you build with friends.